Alright, here are solutions to quiz number 3. It was actually called Requiz 3, indexes other than 2. So I'm going to walk through each one. Your quiz tomorrow will be a shorter quiz than this, but I'll still count it for the same points. So number 1 is the cube root of negative 243. And the first thing you can always do is check with your calculator to see if you can do that. Okay, it certainly is a real solution because I can cube root negatives always, because it's a negative 1 times negative 1 times negative 1 gives you a negative. So it's kind of nice sometimes when you have an odd index and a negative radicand to pull that negative sign out right away. Because now we just have to worry about factoring 243 until we can find 3 of a kind. So I'm going to start factoring 243. It's 3 times 81. And then you keep track of all your factors. 81 is 3 times 27. And then 27 is a 3 times 3 times 3. So if I were to multiply 5 3's together, it's equal to 243. Now the question that a cube root is asking is, what have I multiplied together 3 times? Well, I have 3 3's that are multiplied together. So I've got my negative on the outside. A 3 is the answer to what is cubed, or what is multiplied together 3 times. And then I have a 3 times 3 that stay in the radical, but we don't write 3 times 3, we just write it as a 9. Okay, so there's problem number 1. Problem number 2, we've got the fourth root of negative 81. And right away alarms go off, because this means I have to have an even number of things, 4 things multiplied together. Well, there's no way to multiply 4 things together and get a negative answer. So right away I just answered this as not real. I cannot do that problem. Problem number 3, I've got the fifth root of 243, x to the 25th. If you remember from the first problem, we saw that 243 was made up of 5 3's multiplied together. So that one's done. I want what's multiplied together 5 times, answer 3. So there's the numerical part that comes out of the radical. And now I'm just left with x to the 25th. And the rule for dealing with variables is take the exponent, 25, divide it by the index, and that tells you the exponent on the variable when you bring it outside. So the variable x comes out, and the exponent is a 5. Now 5 went to 25 evenly, so I have no remainder, which means there's no x's left inside the radical. For those who'd like an explanation of why this works, what we're trying to do is find out I need groups of 5 x's. And if you think about x to the 25th, there are 5 groups of 5 x's. And so this 5 and this exponent essentially cancel, giving you just the x to the 5th, because I had 5 groups of 5 x's. Problem number 4, sixth root of 32x12, y18, z21. I'm going to deal with the numerical part first. 32, it's 2 times 16, it's 2 times, and 16 is 4 2's multiplied together. So this right here equals 32. However, that's only 1, 2, 3, 4, 5 2's, and I need to have 6 of something multiplied together. There's nothing inside 32 that I can take outside of the radical. Now I work on my variables. 12 is divisible by 6, 2 times, 18 divisible by 6, 3, 21 divided by 6, no, it doesn't go in there evenly. And so when I bring out the stuff, I'm going to have an x to the 6th. 12 divided by 6 is 2, so x to the 2nd. I'll have a y to the 3rd, 18 divided by 6. I'll have a z to the, let's look at 21 divided by 6. It goes in there 3 times, giving me 18 with a remainder of 3. Okay, so the 3 that it goes into it is what comes out. My 32, remember, did not have 6 of a kind in it, only had 5 2s, so it stays in. And the remainder of 3 is on that z that I had left over. So this is my final answer. Now you notice I'm not talking about absolute values at all. That's because on this quiz I told you let's just assume that all variables are positive, so we don't have to worry about any of the absolute values. Problem number 5. 4xy cubed, fourth root, 162 x to the 4th, y to the 8th, z to the 12th. I'm going to factor 162 is 2 times 81. That's 2 times 9 times 9, and each 9 has a pair of 3's in it. So there's the factorization of 162. I'm looking for 4 of a kind, and I've got 4 3's in it. So a 3 comes out, giving me 3 times 4, 12 on the outside. Leaving a 2, let's go ahead and keep track of what's inside. Leaving a 2 on the inside. X to the 4th, 4 divided by 4 is 1, so an x to the first comes out. I've already got an x to the first out there, so that gives me a total of x times x, or x squared. 8 divided by 4 is 2, so a y squared comes out, giving me a total of y to the 5th. 2 came out, already had 3. And 12 divided by 4 is 3, with no remainder. So I guess I could shorten up my radical symbol there, because all I have left inside is just a 2. And there is the final solution. Problem number 6. Negative 3m to the 4th n, 5th root 128, m4 and 8. Let's deal with the number first. We'll factor 128 as 2 times 64. It's 2 times, and 64 is 2 times 32. And I happen to know 32 is made up of 1, 2, 3, 4, 5 5s. Think about that for a second. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So there is all these 2's multiplied together to give us 128. It's asking the question, what do I have 5 of multiplied together? So I'll count off 5 2's. And those 2's get to come out because they answer that question. So I bring a 2 out. That gives me 6. 2 times negative 3. And inside here, I've got these 2's, those 2 2's still left over. That's 4. Let's deal with the variables. M to the 4th, that's not divisible by 5, so it stays. And to the 8th, 5 goes into 8 one time, so an n comes out. This m to the 4th stays. Another n comes out to join it. Now when I did 8 divided by 5, that gave me 1 with a remainder of 3. And so my final answer, negative 6 m to the 4th n squared, 5th root of 4 m to the 4th n cubed. Problem number 7. It's a radical. I'm going to separate the numerator and denominator like so. Okay. What I like to do first is simplify any radicals I can. So 16 is made up of 2 times 2 is 4 times 2 is 8 times 2 is 16. It's made up of 4 2's. So I'm going to bring that 2 out. And so the problem becomes this. Now I cannot have a radical in the, put my 4 on that denominator's radical. I cannot have a radical in my denominator, so I've got to fix it. This problem says I'm looking for 4 of a kind. I've got 2 n's already, or n squared. So I'm going to take it times another n squared, giving me a total of 4 n's multiplied together. On top I have 2, 4th root, m cubed, n squared. And on the bottom, show it down below here, I've got the 4th root now of n to the 4th, which is just n. And so I no longer have a radical in my denominator, and that's my goal for a problem that has a radical down there. Problem number 8. 2x over 5th root of 8x. I can't take anything out of that radical. I know that 8 is made up of 3 2's multiplied together, but I need 5 of a kind to take anything out. The numerator already is just fine. There's no radical to take anything out of. So I'm trying to fix the radical on the bottom. To do that, I have to take it times the 5th root of something. Well, if I look at the denominator, it's got 3 2's multiplied together, so I need another pair of 2's to give me a total of 5 2's multiplied together. I've got 1x, so I need 4 more x's. And I have to do the same thing to the top. I can get it here, 2 squared x to the 4th. Now, so you can see what's going on in the bottom now. What I have, when I multiplied 3 2's that are in 8 times 2 more 2's, I get 2 to the 5th. And here's an x to the 1st times x to the 4th. I get x to the 5th. And that's what I want to happen, because now I can 5th root the denominator. Numerator I can't do anything with. What's the 5th root of 2 to the 5th? It's 2. What's the 5th root of x to the 5th? It's x. And you can see I get a little bit canceling right here, and so my final answer is the 5th root of 4x to the 4th. Problem number 9. Cube root of y squared over the cube root of 3. The denominator has a radical. I need to have 3 of a kind down there, so I'm going to put in a 3 squared as a factor. On the bottom now I have 3 times 3 times 3. Cube root of that, 3. On the top, I've got 3 squared, 9, and a y squared. And I'm done. Problem 10. Now you got to read the directions on these. It says rewrite without a radical. So essentially that just means take it from radical form into exponent form. Remember, the exponents are in the numerator of your exponent, and the radicand is in the denominator of your exponent. And now I'll simplify these. 6 to the 1/3, x to the 4/3, y to the 3rd. And there I've written it now without this radical symbol. 11 is very similar. I think a lot of people missed this one, and probably the previous one. They forget that on this 8 there's an exponent of 1. So that's 8 to the 1/4, x to the 10/4, y to the 2/4. Again, this 4 down here is because that means 4th root. We'll simplify these fractions to have the best answer we can have. And y to the 1/2. Problem 12, now directions change. Now it says, hey, don't write it with exponents. Write it all as radicals. So we're going to go 5th root of all this stuff in here, and then it says squared. So let's square the stuff inside there. That's 64, t to the multiplication property there for exponents, t to the 6th power. Problem 13, same deal. Rewrite this as a single radical. Now you'll notice in this problem, this 5 means 5th root, 2 means square root, 3 means cube root, but I want a single radical, so what I have to do is get them all so they have the same denominator. I'm going to go for 30, I think, is the least common multiple of 5, 2, and 3. And so if I blow each fraction up so the denominator is 30, I'd have to take this 5 times a 6, so I have to take the 2 times a 6. I have to take the 2 here times a 15, so I take the 1 times a 15, that's still a half. And I have to take the 3 here times a 10 to get 30, so I take the 1 times a 10 also. And so my answer as a single radical is the 30th root of a to the 12th, b to the 15th, c to the 10th. Problem number 14. 14, the directions are just simply simplify this radical. For this one, I would notice immediately that on the top I have an exponent of 1, which is bigger than 4/7. So I'm going to use the subtraction property of exponents and just go 1 minus 4/7. Now you can use your calculator for that thing, but I'm going to just get a common denominator of 7/7 minus 4/7, which is r to the 3/7. And now I don't have this radical in my denominator, and that's my simplest answer. And finally, number 15, negative 8m to the 6th n to the 9th raised to the negative 2/3. A lot of people have a hard time with that negative. It just means do the reciprocal of what's below it. So it's the same problem as this. Now to the positive 2/3. There's a lot of ways to work this. What I'm going to do is I'm going to go ahead and use the 2 here, and I'm going to square everything. That's what that 2 means to do. 64 m6 n9 all to the 1/3 power. Notice the 2 is no longer there. It's just a 1 because I've squared everything. Now this 3 means to cube root everything. So let's work over here. I want the cube root of all of this stuff. Well, the cube root of 64 is 4, because it's 4 times 4 times 4. Here I use the division property. It's 6 divided by 3 is m squared, and the division property, 9 divided by 3 is 3. I don't have any radicals in my denominator. I've taken care of the exponent, and I'm done. Hopefully that will help you as you prepare for the quiz retake tomorrow.